Hi, this is Kumaravel. In this lecture, we are going to discuss about critical frequency of an antenna. So, what is critical frequency? As we know that when we transmit an electromagnetic wave, it will propagate it through different layers of an atmosphere. If we consider if our signal is propagating through ionospheric layer, okay, so critical frequency is the maximum frequency, right? If your operating frequency is lesser than the critical frequency, so our transmitted signal will be reflected back to the earth as it is represented in the diagram. Okay? If our operating frequency is greater than critical frequency of the layer, then signal will not be reflected back, it will be, okay, it will be propagated. Okay, so however, if our operating frequency is lesser than or equal to critical frequency, then whatever the signal which we transmitted, it will be reflected by this ionospheric layer. So now it will be reflected back to the earth. So critical frequency is the maximum frequency by which your the layer of the atmosphere will be reflected back to the earth surface. If your transmitted signal is greater than the critical frequency, it will not be reflected back. Okay, so we have to know always our operating frequency should be lesser than the critical frequency of the corresponding layer. So now we will see the mathematical equation for critical frequency. So we know that what the refractive index of an ionospheric layer, the equation is given by n equal to square root of 1 minus 81 n divided by f square. So here f represents the frequency, n represents the number of electrons in the respective layer. Okay, so now using Snell's law, we know that n equal to, right, incident angle as well as divided by the refractive angle. Okay, so now we can relate these two equations directly. Okay, so now if our angle of incident is equal to 0, then what I just considered angle of incident equal to 0 and n to be the maximum number of electrons in the corresponding layer. Okay, then f to be the critical frequency. Therefore we can rewrite this equation as 0 equal to square root of 1 minus 81 n maximum divided by fc square. So now we can rearrange this equation to find the critical frequency fc. So how we can do? So we can take squaring on both sides, so we can eliminate the square, then we can rearrange this. So we have squared on both sides. So 1 minus 81 n maximum divided by critical frequency square equal to 0. Now take this parameter towards your right hand side. Therefore, we will have what? 81 n maximum divided by critical frequency square. Therefore, critical frequency square root 81 n maximum. Therefore, Fc is equal to square root of 81 n maximum. Finally, the critical frequency is 9 multiplied by square root of the n maximum. So what is n maximum? N maximum is nothing but what? Number of electron in the corresponding layers, which represent basically, so number of electrons in the cubic meter. Okay, thank you.